Hi guys, in this video we are going to dive deep into the Node.js streams and learn how to handle one of the most important but often overlooked concept, that is nothing but back pressure. So what is this back pressure? So you'll see how the high watermark works, how stream.write behaves, and how we can handle the drain events properly to keep our code efficient and safe. Let's get into it, this one. So now if you try to understand our code, so here we have seen, right? We'll have a quick recap about this one. Streams in Node.js have an internal buffer, as you people already know about that one. And the high watermark defines the maximum number of bytes to store in the buffer before pausing the writes. When the buffer gets full, Node.js applies what is called as a back pressure. So we'll try to see this one. So here we have created a file, okay, and we have created the create write stream. And if you want to know this one, so this is the high watermark. So right now what we'll be having, so we have a writable stream with a high watermark of around 16,384 bytes, I think. That means if you try to write more than that, Node.js will return false from this stream.write. So whenever you are trying to write the stream.write, it will return false to signal us to wait. So let's try to see this one. So for example, let's say that I will close the okay, I will close this one. I will remove this one, and here writable length and all those things we know. Now we understood about the buffer allocation. So here what I will try to do, here I will create 16,384. So I am creating a buffer like this. So now if I try to console.log of buffer, let's see how much memory allocation it has been done. Here I will do node write mode.js. So here 16,384 bytes of data has been created, buffer has been created. Now what I will try to do here, I will try to write the console.log stream.write of that buffer, the entire buffer. I will try to write it, and I will check the what I mean to say, the return type. So now whatever the high watermark is there, so I have created the buffers with the same memory, and I am writing that buffer into the stream, and we'll try to check whether it will return true or false. So now if you see here, if I write it here, see it has written false. Why? Because the entire buffer has been, since we wrote a buffer that fills the stream completely, this write method call will return false, indicating that the stream is full and we should stop or pause the writing. So here we have written. So for example, let's say that I have decreased one byte and I am writing it. Let's say that whether it will return true or false. So if you try to see here, it returns true. So that means the buffer is still little bit of empty to fill the data. That is nothing but 1 byte. For example, let's say that here I will create another buffer or otherwise console.log stream.write, and I will try to create buffer.alloc of 1 byte. I am creating a buffer of 1 byte. Buffer means here it should be like this, 1 byte, and I will fill it with something A or anything. Okay. Now let's see that whether it will the first stream what it will try to return, and the second stream what it will try to return. Now if you see the output for this one, so the first one has returned true. That is nothing but the stream still has, the buffer still has inside the stream has the memory to fill the data. But when we return 1 byte of data, it immediately return the false. So that means the buffer inside the stream has been filled. So notice the difference. Even if the buffer is even 1 byte less, stream.write returns true, meaning it is still safe to write. So even if there is 1 byte less also, it is returning true. Why? Because it is still safe to write. So now if you ignore that false, so now here it has written the false value, right? If the memory is full, if you ignore that false return value and keep writing, your buffer just keeps growing. That's called as back pressure. So for example, let's say that again you are going on writing this one. Okay. So it will go on create a back pressure. So here we'll try to see about the console.log of writable length. Okay. So let's try to see about the writable length. Okay, stream dot writable length. Writable length. So first of all, let's try to see up to here only. Oh, sorry. So now here if you try to see high watermark and writable stream, Now I will remove this. Okay, let's keep it like this. So now if you see here, so 16,384 is the high water mark, and the writable length has written the 16,384, such why it has written false. For example, if you go on writing this one, okay, now let's try to see the writable length, what will happen. So let's try to see it. See, if you try to see, the memory has been increased. Okay, this is that's bad, so we should not do it. That data without checking if the stream is full means that's bad. We are overwhelming the stream's buffer and risking our memory issues. So this will be going on writing the memory, even the high water mark, and it will rise into a memory issues. So how to handle this one? So now we are able to know that when the stream.write return false, we are able to understand that the stream is full or the buffer is full. So now how to handle this one? So now instead, when the stream.write return false, so we should pause and wait for the drain event. Now the stream always returns a event. So when the buffer is full, so when the buffer reaches the maximum high water mark, okay, so writable length is equal to the high water mark. So this one return false, and immediately when the data has been drained, it will emit an event. That is nothing but a drain event. So how you can capture the drain event is, for example, let's say that here stream dot on off drain. Okay, so this is the drain event, and here you can have a callback method, and here you can write something like console.log. You are now safe to write more. Okay, so this is the drain event. Now let's try to see this one. So now you are safe to write drain, right? Let's try to see the output for this one. So let's try to see whether we can able to get it or not. So we are not able to get it. Why? Because we are closing the file, which should not do it. Why? Because when we are closing the file means automatically the stream also will be closed. Let's see whether we can able to drain it or not. So now if I try to write it here, see, it is taking 16,386, and here it is showing you are now safe to write more. So that means here the drain is happening. So that means here, yeah, now exactly it matches, right? Immediately the drain will happen. Now here let's try to see. See, now here you are now safe to write more. So that means drain event has been fired. Now if you try to check the writable length in the drain event, it will be again 0. So here you will be able to see. See, it is again 0. So that means the buffer has been emptied. So this is how you need to do it. Okay. So when the stream has finished flushing its internal buffer, it emits a drain event. That is your signal to safely write more data. So here when the event is emptied means then it is a signal for you to write the more data. So for example, let's say that if you are closing the stream immediately means after writing, you will never get the drain event. So here I have closed this file handling close, I have did it, right? So now if you try to stream.end or something like that, if you try to use it also, you will never able to get the drain event. Why? Because we are automatically closing the stream too early. So we are not waiting for the drain event. So that is the main thing. So for example, let's say that you also should be very careful. For example, let's say that here you are having the drain event. Okay, we are having this 683, this one, right? Let's say that when the drain event is done, again you want to write this one. Let's say that here 684. Let's say that you are filling this one. Sorry, stream.write of buffer. Okay, again you are writing. Let's say that you are trying to write this one. Now this goes into a loop back. Okay, so this will be a loop. So if you try to see here, so it will go into a loop. Why? Because you are trying to fill again when this drain is happened, again you are trying to fill the buffer 684, and this one again you are trying to write in the stream, which returns the false, and again the drain event will be fired. So this goes into a loop. This code causes a drain write loop. So this goes into a loop. Use conditions or control flow to avoid it. That is the main thing. So now just try to recap what we have learned, how to handle the back pressure. So let's summarize what we have learned up to now. First one is the high water mark, defines your internal buffer limit, and also stream.write returns false when the buffer is full. If it returns false, we need to pause the writing and wait for the drain event to resume the writing. Never let the stream or writable length exceed the high water mark. That is the main thing. Don't blindly write in a loop. Always check the return value. So here, so the loop thing, you don't blindly return. So now we are able to see about this writable high water mark and all those things. So this is what about the drain event and also the writable allocation and all those things which I want to tell you. Okay. In the next video, what we'll try to do is we'll try to implement this in our file writing thing, and we'll fix our for loop. So here I have mentioned this for loop, right? So down here, this for loop, how we can stop it and how we can write it. Let's fix it in our next video. That's it, guys, about this one. So, and that's how you will handle the back pressure and drain events properly in the Node.js streams. If this video helped you understand streams better, hit the like button, subscribe for more content like this, and drop a comment if you want to have a deep dive in the buffers next. Thanks for watching.